Hey guys, Dennis here, and tonight I'm making a little part out of this piece of aluminum. This is a little cutoff from a bar of 7075. I want to show you in this video a way to machine aluminum without using a real mill. I used to have access to a mill and it was awesome and I loved machining, and now I don't, so I have to get a little bit creative about how I make parts. Alright, so to start, you do need some precision parts to, and that's this little ground V, I forget what it's called, V block I guess. Something round can sit in the top here, and it comes with these clamps. Basically this will ensure that now this cylinder is going to be straight across relative to the bottom of this. We're going to get our precision out of this setup. So let me tighten this up. Because I already made one of these and I kind of learned from experience, you can hold on to this, but it doesn't give you much purchase. Really, I'm just trying to be cheap here, and I want to use every last bit of this cut off here. So it would be easier if I just used this bar, but what I'm going to do is also clamp this one to give me something to hold on to. So now I want to mark where I'm going to cut, because I'm going to start my cut on the bandsaw. Again, you can use a hacksaw here. And I want to get really close to that line because I'm going to show you what I'm going to do next, and I don't want to have to hog out a lot of material on this operation. The final operation is going to give me my very flat and precise bottom here that I'm looking for. I can't take a lot of material off. So this is a cut off of an aluminum plate, flat enough for my purpose, and I'm going to use this to reference off of. And I'm going to measure from the bottom of the plate to the top of the rod here. What I'm going to do is I'm going to zero it at the top, come down half of an inch. So the rod's getting in the way now. All right, so now I know that from the bottom of this plate to where the calipers is, it's just under halfway on the rod. So I'm going to scribe a line all the way around. Okay. Alright, so I'm pretty happy with how that came out. Let me see if I can focus in. So, right up to the line. Actually, maybe a little bit closer than I would have liked, but I think it'll work. It'll work out just fine. So now the trick. We're going to use a router table now, kind of as a mill, but upside down, and we have to hold our workpiece. This is where it can get a little bit hairy because we're cutting metal freehand, basically. But as long as you take very shallow cuts and are very cognizant of your surroundings and how you're holding the piece, and if anything feels wrong, just let it go. Just forget that piece and just, you know. I'm using a 1/4 inch 4-flute end mill. So this is probably one of the safest end mills that you can do this with. 4 flutes means it doesn't have, it's not going to grab on too much before hitting the next flute. And it's 1/4 inch, so it doesn't have a lot of torque to it. I mean, the router has plenty of torque. This will go right through your hand if you're not careful. But the end mill itself, if it gets stuck, it's a 1/4 inch versus maybe if you wanted to be tempted to use like a 1/2 inch or something. Anyway, small end mill. This is made for cutting metal. It's just on my router table. I got a standard router underneath here, and we're going to eyeball it, but we're going to eyeball it to the line that we very precisely drew on our part. So yeah, we're not going to indicate this, and we can't. I mean, we're using a router table. is ridiculous. I'm gonna move my camera. Okay, so first things first, we got to set the height. And for the first cut, you want to basically have it just barely kissing that bottom of the part, because you don't know if there's a high spot that you haven't really noticed or whatever. You don't want it to grab the piece right away and ruin it. So, okay, try it right about there. So it's pretty important to understand climb milling versus. I know the end mill is going to rotate this way, and I want to bring my piece into the end mill so that you're working against it. Because if you go this way and you have a kickback, it's gonna kick back. You'll go this and it'll kick the workpiece out of the way. What you don't want to do is something called climb milling, where you're going in the same direction as the flutes, because the flutes will just grab the piece and then just fling it across in the direction that you're going. And the reason it does that is because there's still meat behind here. So it's kind of like self-regulating when you're going against it. When it pushes itself back out this way, it's already milled that area, so there's nothing for it to catch on to. So you want it to, when it kicks back, basically to kick back in a direction that it's already removed the material. It's not going to, I'm going to go in 1/8 inch passes, so that I'm only at half of the end mill's ever cutting anything on the aluminum. So, all right, let's give it a first pass. All right, so that was a really good first pass. As you can see, mostly it wasn't even touching, and there was just 2 little spots that it just barely hit. So now I know that I can, raise this up just a hair each time, and I'll be cutting at most the amount I just raised it up. So no surprises. Raise it up just a hair. Make another pass. Crap. All right, so it's not ruined yet, but something happened that didn't happen the last time I did this, but I knew it's a possibility. The end mill has crept up. So these kind of end mills, the way they cut, they tend to scoop the chips, well, in this case, down, but that tends to kind of want to pull the end mill out of the collet. So I need to tighten this down and make sure it's really cranked down, and I might want to put that end mill into the collet a little bit more to give it more gripping power. So I'm going to do that. All right, let's see. This should be almost the last pass, if not the last one. One more. And I'm increasing only by a 1/64 of an inch. All right, so I'm pretty happy with how that came out. It's a really nice machined surface. But we're not done yet. I also want to cut off this top part. I do want this to be parallel to the first surface that we just machined. But how are we going to get the other side flat in parallel with this plane? Well, so this right here is another piece of what I like to call cheap precision. This is a little angle cube that doesn't tell you absolute level, but if you put it on a surface, you can zero it out on, oop, that's just turned it off. Zero it out on any surface, and it's very accurate to tell you relative angle. So this is really great for woodworkers because you can set your table saw blade really easily this way. It's magnetic, so it sticks to saw blades or vices or whatever. In this case, what we're going to do is flip our part over. Again, zero that out. Now we'll put this on the surface we just machined. We can see, I thought that was actually right on, but it was several degrees off. Wow, that's right on. Okay, so 0 degrees right there. Let's tighten that up. All right. Easy as cake. So now we know that this surface here is parallel with the bottom here. It's completely same angle. Genius! And to scribe this one, I don't even need to, I can do it relative to this surface here. What I'm trying to do at this point here is also kind of lighten this piece because this is going to be a precision lightweight tool eventually, and I'm going to make a video about that later, but I don't want to just quite let on about it yet. So I'm going to cut this on the bandsaw and then bring it back over here, do the same thing. Yeah, so I'm super happy with how this turned out. You don't need fancy tools to do metalworking. You can do a lot of stuff by hand or improvise with woodworking tools. One last caveat is that you might be tempted to do side milling with an end mill in the router table. I wouldn't. I tried it, and I even clamped a board to try and get this part to go straight across the side of the end mill. You're not going to get enough rigidity to be able to do that. You might be able to get away with it with a bigger end mill, but it gets kind of scary. My recommendation, don't try side milling. This would be strictly for cleaning up a surface like you saw. Specifically, this is a great use case for this kind of technique. I've done it a few times now, and it's not too hairy. In my mind, it's not that much more scary than some woodworking operations that I've done. Alright, so that's all I got. I hope this was informative. I'd really like to hear you guys' feedback, comments, questions down below, so please let me know what you think. And if you liked it, please do hit that thumbs up so that I know. It really helps me feel better about myself. Of course, if you're not a subscriber and you like this video, you might want to click that subscribe button down below, so do that now. Click the bell next to it so you'll get notifications, and we'll see you next time. Thanks for watching, guys.